Good afternoon. This is paper ID 165 entitled Terahertz Wave Emission from Silicon Nanomaterials Synthesized by Horizontal Vapor Phase Epitaxy. I am Christopher Ke from the Physics Department with Professor Nonato Santos and my former students Anjamine, Perigo, and Arra, Sebastian. Terahertz wave is part of the electromagnetic spectrum and lie in between the microwave and infrared regions. The useful range of terahertz wave is typically from 0.1 terahertz to 10 terahertz in frequency. 1 terahertz is equivalent to 1 picosecond, 300 microns for wavelength, 33 per centimeter for wave number, and has a non-ionizing energy of only 4.1 millielectron volts. Due to this low energy, terahertz wave is used in several applications, one of which is non-invasive detection of harmful materials. This figure shows an ordinary brown envelope where one side contains a C4 plastic explosive. Under terahertz absorbance spectroscopy measurements, one can determine the terahertz absorbance fingerprint spectra of C4, as can be seen from this graph. Emitters of terahertz waves are usually fabricated using molecular beam epitaxy, which is quite expensive. In this study, we fabricated silicon nanomaterials using a more economical method, the horizontal vapor phase epitaxy. 35 milligrams of 99.9% silicon powder were placed inside a glass tube that was sealed on one end and ultrasonically cleaned. The open end of the glass tube was then inserted in a high vacuum system and evacuated up to around 10 to the negative 6 Torr pressure. Maintaining the pressure, the open end of the glass tube was then sealed. The vacuum-sealed glass tube was then placed horizontally in a tube furnace and baked at 1,200 Celsius for 7 hours. This is the image of the glass tube with silicon nanowires after baking. Surface morphological measurements of the baked sample reveal silicon nanowires at 5,000 and 10,000 magnifications, respectively. To verify its terahertz emission capability, the baked silicon nanowire sample was placed in a terahertz time domain spectroscopy setup and was also compared with a P-type indium arsenide terahertz emitter, which is known as the best bulk semiconductor terahertz emitter to date. A mode-locked titanium sapphire laser was used to excite the surface of the emitters. Results showed that silicon nanowire sample emits terahertz waves, as can be seen in this figure. The terahertz signals from indium arsenide and baked silicon nanowire are 2.5 nanoamperes and 1.4 picoamperes respectively. Although the emitted terahertz signal from the silicon nanowire sample is still far from that of indium arsenide, we have shown that terahertz emitters can also be synthesized using the horizontal vapor phase epitaxy method. Thank you very much.